Good afternoon, everybody. Thanks so much for joining. Good evening to those that are on the other side of the world. I apologize for the late start today. I had some stuff going on this morning, but here we are. Today we're going to be talking about SSH, and I need to mute the stream up here so we don't get feedback. There we go. Okay, great. Looks like we're good and live. Okay, sweet. All right, so as promised from last stream, this is going to be super raw, everybody. Just buckle in for that. Um, I'm trying to do less preparation for these because it's eating a ton of time because I said it wasn't going to be polished, but that's hard for me. I like to have a plan, but we're just going to start hitting stream and see what happens. So in this stream, we're going to be trying to get SSH, an SSH server working on the ESP32. Now, why on earth would you want to do this? Well, you might not, depending. The ESP32 is a little bit of a constrained platform to do something like SSH, but the case for this is secure connection to a device. So most times when people need to do some form of remote connection to an ESP32 based product, they kind of roll their own protocol or um, communication layer there to do that. And so you can do it over different transport channels. But with SSH, you get an industry standard, known, battle tested mechanism of doing that you can ensure is secure. So, but as part of that, I wanted to see like how big is it, how heavy is it. Maybe it's lightweight enough that it makes sense for certain um, products where you'd want to be able to SSH in. So that's what we're going to take a look at. Here is a project on GitHub that we're going to be working out of. Let me drop this into the chat. Let's do that. Make sure chat works. Good evening from the other side. Hey, everybody. Thanks so much for jumping in. Let me see if this comes across. Okay. That should have at least come through on YouTube. I don't think my comments from the chat here go into LinkedIn. So let's just come over there and let's drop it in manually, like so. Okay. And then let's see. Yeah, okay. It looks like stream is live here as well. All right. Excellent. Okay. Let's just get right into it then. Okay, so we are working out of the same. Oh, sorry, geez, getting ahead of myself. Before we do that, quick update. For those that were on the last stream, we were trying to do, not trying to, we did. We successfully did, without bricking, enabled flash encryption on our ESP32. So two things I want to remind you. Remember, we're using our little dev kit here, nothing special. Get any ESP32 dev kit will work. If you are messing around with this and you've got, like I do, I've got this dev board over here and I've got like 15 of them sitting behind here. And now that this is flash encrypted, I like to do something, maybe not with a marker, because again, you can turn flash encryption off, but some way to note that this thing is flash encrypted. So it's not a big deal if you flash, as we showed in the stream, if you flash non-encrypted, you'll just get an invalid header error over and over and over. But anyway, just to keep track of, that becomes super important if you're doing secure boot, because once you enable secure boot, you're there. And so with a specific key, you have to sign firmware with that key, and so that's when it gets really important to mark or somehow identify those development boards so that you don't get them all mixed up. And then they are kind of bricked because then you don't remember the key that you use to sign the firmware, and it's a whole big deal. So that's the first thing I wanted to bring up. Second was I did log a bug, NVS encryption not properly including the NVSsec provider component, and it looks like they have acknowledged right here, yes, you are right. Then they say like, oh, here's a way you can get around it, and I'll see if we can get it fixed. I didn't love the dedication to getting it fixed. It felt a little soft, so I kind of came back in with another comment here on the issue saying, hey, like it really should not work the way that you're saying it might have to. Saying, you can add it to the require section. But you definitely should not have to do that. They've built an abstraction. The abstraction should work out of the box. So anyway, quick update on that from the last stream that we ran into. So, okay. And again, we're working out of this github.com/david-cermak/libssh. He did a port, like it says right here, a minimal ESP IDF port of libssh. And so we're just going to see if we can get this thing up and running. The part I'm most worried about is my connection. My Wi-Fi network is kind of like more pro than it needs to be for all this IoT testing. So I'm actually streaming from a network that my device can also connect to. That way I can, at the end of this, hopefully from a terminal connect. And so hopefully the stream doesn't suffer from that because it's my IoT Wi-Fi that I'm streaming from so that my device, so I can see my device. Anyway, boring, you don't care. Let's just get into it. All right, we are using the same project that we were using last time. So this is the exact same, just dummy, very bare bones, connect to Wi-Fi and then print out the version. We don't need to print out this super secret key thing anymore. That was for flash encryption. And that's it. So I've got the instructions up over here on the side, so I won't be flipping back and forth through those. But the general idea from the instructions is just that you need to grab the libssh folder from this repo. Now, it would have been nice if, actually, let me just go back and show it to you really quick. I would just include it as a submodule, but you see if I clone libssh, I'm going to have a libssh right over here folder in it. And so I would have, it would be redundant. I'd have libssh under my components, and that's not how IDF likes it. And so what we're going to do is we're going to clone this, and then we're going to copy the libssh folder. So just if you're ever doing this and you want to make a component that people can just submodule into their IDF project, don't do this. You'd want to take everything that's here and put it up at this basically example server. All this stuff should be at the root of the project because that's what needs to be cloned into your components folder. So let's grab the URL. Let's jump back up here. And I don't know that I want to clone it right here. So let's go up a level and clone it into this. I think I should be able to do that. Yeah. Oh, yeah. Can't just put URLs in the permission denied because it doesn't like. Yeah. Let's do a make dir temp cd into it. Let's try that again. When you're in a Docker container, I love it. You should do it. 2 streams ago we covered it. Since we aren't root, we only have permissions to certain things, which is the workspaces folder here, and the home directory. I guess I gotta clone it there, but all right. So now let's do a, geez, my Linux foo, copy temp. No, I'm in temp. Copy libssh to / components. Yeah, I think that works. Copy -r. And then if we come back over here to our files, we should see libssh. Great. No, because I did that. See, I just made the mistake. Delete. We need a cd into libssh and then do that. Or not. Why do we? Why? Okay, because another folder down. There we go. Okay. Making a mess of everything. I've got components in here now. Let's just get rid of that. Okay, so reminder for those that are new to IDF, that are maybe coming over from the Arduino ecosystem. Arduino's super famous, lots of packages. You can just install libraries after libraries after libraries, and it's really fun and easy. Components is the raw IDF version of that. And so you've got this components folder, and you can drop in, and I mentioned this in the first stream. Sometimes if you're using Arduino Core, and I'll show how to set that up in another stream because I think that would be helpful for some people. If you're using Arduino Core, you may be able to take the Arduino library just exactly as it's included in the Arduino IDE and drop it into the components folder and have it work. And so, but this is where, just so you're getting familiar with the IDF, this is where your Arduino libraries go in IDF parlance. So we've got this libSSH here, and then he includes an example and has some SDK config defaults here that let's take a look at. Do I have SDK? I do have it set up here. Okay. So let's just take all the defaults that he has. The very top one, I'm not going to grab config partition table single app because I have my own partitions set up. So we're going to copy all the rest of these. We're going to bring them down to our SDK config.defaults. Now, when you do this, you have to rebuild SDK config. The easiest way to do that is to just delete it and have it be regenerated. So yeah, I wonder what our main text stack size is probably that big. All right, so we've got that, and then port. Oh, he's pulling. Ugh, I see. You've got to have. So he didn't do the. Hmm. Yes, I see. The whole server. He's got the. So this is not going to build like a component. Yeah. I'm not sure why I was. Well, I guess. No, it should. Port. Yes, it should. Sorry. I thought port was under example server. We should be fine here. So let's look at example server and then the CMake lists. He is doing this target add binary data server elf, and this is the key because we got to have a public private key and nothing else in there. Let's look at the CMake list in here. Just server.c, so nothing crazy there. And then, okay, so I'm going to grab this line of code and I'm going to drop that into our main CMake lists. Actually, that's at the top level. That's the top level C. Yeah, so that's not where I want to add it. I would want to add it in this CMake lists. Yep, project. Okay, and mine's, well, yeah, I'll move it over into there actually. So let's just grab that key. Is it the host key or the pub key? It's the key. So this is the private key. So let's copy that file and put it into our main. So that's good. And yeah, so that looks good. Server. And then we'll need the public key. I sometimes I forget how SSH stuff works. So, all right. And then in the main, yeah, he's just doing the register components, so nothing special there. And then the sort. Then he's got this. This is how you actually use it. And so we should be able to basically take this and drop it into our main. Let's just grab the whole thing and come into our main. Main.cpp. I'm CPP. He's using C. That may or may not be a problem. Okay. And now I think the only difference, like I think I want all of this code And then the app main is the only thing that we're going to do a little different. So let's hoist all of this to the top, including all the includes. And see what kind of overlap we have. So like standard IO, we've already got standard lib, string.h. Yeah, I don't know that we're going to have a lot of overlap. NVS flash, I've already got. ESP event, I should have as well. ESP log, we don't have because I'm using this like DTF logging stuff, which is unimportant. The protocol examples common is how a lot of the expressive examples do how they do connection to Wi-Fi. So I'm gonna get rid of that. And then here's the SSH stuff. So we're gonna keep all of that. So that'll be great. So let's take all of, well, that can also just stay there. So great. So we're gonna keep all of that. And now what I think we'll need to do is in our CMake lists, we're gonna do requires let's come up to the top. Remember, set components, I have specifics, so we got to identify which ones we're going to include. So I'm going to say lib SSH, which I believe is what that one's called up here. Lib SSH, yep. And then in our main CMake list, we're going to require lib SSH. And that should all be fine. And then down here in the app main, yeah, so we have to do like flash init, netf, all of this stuff we already do. We already have, so in our app main up here, I already do NVS flash init, connect to Wi-Fi does the rest of that. You can see we've got netif init, default loop, event loop. And so all of this we don't need. This is initializing libssh. Okay, and he's doing that after connecting. So basically the whole rest of the app main here. SSH finalize, yep, let's do that. After connecting to Wi-Fi, all the rest of this code is setting up the SSH server. So let's take it out of there app main and come up into here and do, instead of this while true, we're going to put all that code in. And then now we should have basically his example of the SSH server, if I'm reading that all correctly. Okay, so there is zero chance this is going to build first time from me just doing copy pasta there, but you got to start somewhere. So let's get back up to where we want to be. Let's clear, do idf.py build. I hate how that's just cutting off like half a line there. That's annoying. And see what kind of crazy errors we get. There we go. libssh include is not a directory. This is in components. Where are we getting that from? Unknown kconfig. Base. Okay. So for the setup, the way he was recommending it, was using the component. So let's see, manage components. What did it just add? Add sock utils, okay. Which is fine. And then we've got this IDF component. We could do it from here as well, but yeah, I'm not sure what components libssh0 include is not a directory, which it is not. Libssh, it's under port. Okay. And then under port, we have libssh. And that's really it. Are we missing a bunch of stuff? No, it's like everything. Okay. Oh, and then under libssh, yeah, it's just the version. Okay. Well, what all are we? What else are we missing? Yeah, because I guess where I'm at now is this doesn't have any code. Like there's no like we've got libssh and it's got a little bit of header here, but there's no IDF stubs. Like there's no libssh. Like there's no the library's not here. And I've got this install. Let's see, IDF components, sock utils, great. This script downloads, extracts, and builds libssh from source. I mean, is that what we need to do here? I don't think that's going to work in my Docker container, I guess, first of all. Yeah, because it's showing, the CMake list here is showing a lot of files that do not exist here. Agency, AUSC, base64C, like these things don't exist. And so is that what this is giving us? CD components, libssh. I do not think this is going to work. Shows you how much I know. Boom, look at all that. Okay. So I wonder if there's another way to submodule that as well. Okay, well, cool. Looks like we got the source code now. Now the build's going to get gnarly. Py build. Okay. Sources for target server.elf, which is not, oh, yes, because, yes. Okay, great. This is all great IDF learning stuff. If we don't get SSH working, we'll at least learn some stuff about IDF and the development environment. Okay, so let's go back to our top level CMake list. Let's get rid of this. We got files galore open here. Add on. Hey, I am not sure how to pronounce that name. Detekri? Deepal? I'm gonna call you Deepal. Sorry. Rock Wireless has their block boards. I know for running SSH on one, you need their encryption chip add-on. Yeah, we shouldn't here. We're going to use a public-private key that we are just going to put in. I'm not promising great performance on this, but it's supposed to work. Okay, so in our top-level CMake list text, we've got this target add binary data. So what we're saying is we're going to take the contents of this main SSH host ed25519, which is, as we showed a little earlier, scroll up. This is just our private key, and we're going to embed it in the binary, and it's going to do that in server.elf. Well, server.elf is not what we're building here. And so if we come up to the example CMake list, you can see that the project here that he created is server. So when you build, it's going to create a server.elf. which I'm not sure. I thought you would just say server here, not server.elf. But in any case, ours is going to be called something different, which will be in our CMake lists, which is DTF SDK Playground. So we can do DTF SDK Playground.elf, which should resolve that build error. Okay, that actually made it significantly farther than I thought it was going to. Okay, redefinition of app main. Oh, this is the stupidest error ever. Watch this. Come into main.cpp, and I think I just left it down there hanging out at the bottom. I sure did. Look at that. Let's get rid of that. So with most of these things, this is basically the flow that I go through, like build, error, like tweak. All right, I'm going to have to just leave this up because we're going to probably do a lot of these. Designator order for field does not match declaration order. Okay, this is another great error to get. So you're going to get warnings galore. And the reason we're going to get warnings galore is because in his example, he was using server.c. So he's building that with a C compiler. Much, much more forgiving and accommodating than the C++ compiler, which will start to turn into things like warnings. But in some cases, C++ is going to say that's an error. You're not getting away with that. And you can turn these off. But you shouldn't, because C++, this is the way the compiler is trying to tell you, hey, you're doing something that, while it may work, is likely to bite you later. And so in this case, it's saying the designator order for this field, the SSH server callback struct, does not match the declaration order. So let's just control click on that. It's going to take us there. And it's showing us we're creating this SSH server callback struct, server CB, and we're initializing it in this order: user data, auth none function, auth password function, channel open request session function. But if we go to the definition of this, which I'm hoping it will show us, oh, it might not because of how, like our search directory should, it still should. Let's see. It's going to be, well, it's going to be somewhere in the libssh stuff. This code, can we do a search? Include path. It should. IntelliSense should get us there. But just for fun, let's do, I think we can do that, but I'm going to go a step further and say workspace folder / component / I'm just going to go all the way libssh. Basically telling IntelliSense how to find those things. So it should go back and like re-parse and hoping eventually say, yes, I know where to find this. The other thing we do is just Control-Shift-F, SSH, server callbacks, callbacks struct. Okay, proxy.c, we're going to basically look for a header file here. Here we go. That's test server. That's not going to do it. Okay, great. It finally, so IntelliSense got there. So let's minimize. Sorry, I've got limited real estate here on the screen, so I apologize. And I've got the font a little bigger, so it streams a little better. Let's split this to the right. Oh, we're really getting tight here. Okay, so now set up server callbacks. You can see we're doing user data, auth none function, auth password function, channel open. But the way this is, don't set this size t. So there's a, that's interesting. We are using, but you got to init it to, like the struct gets initted to something. You can see it's user data, auth password function is the second thing, then auth none function. So we have those backward. And then we got a couple other things. So a lot of times you'll get a warning saying you're missing an initializer for a struct because it's going to get initialized to something. And that's why the compiler is trying to tell you, hey, you should explicitly initialize this. Otherwise, it may not initialize with the value you're expecting. But in this case, I think all we need to do is switch the order of these. And that particular error should go away. Let's build again. Okay, that built. I don't know what's gonna happen when we run it, but it built. We got rid of all the errors. So yeah, tons of warnings, and you can see, this is what I was just talking about: missing initializer for member this, missing initializer for member. Because again, the compiler's saying, hey, you're creating a struct that has 20 members, but you've only provided initial values for 5 members, and so it's going to tell you about the other 15 that you didn't. And you can actually turn this into an error in your code base, which I highly recommend if you're in a production environment. You can do that with some settings up in the CMake, the global CMake lists for the project to say, hey, treat this compiler warning as an error. And I like that just for keeping the code base, nice and high and tight and a little better. Okay, so I have no. Let's just go straight for it. See what happens. We're half an hour in. Like we need to get moving here. And I'm lazy and I could just type the command, but I'm gonna hit up arrow until I find it. IDF encrypted app flash. Remember, once your flash encrypted, you got to do this encrypted app flash instead of flash or app flash. So we're gonna do that and we're just gonna see what happens. Who knows? I don't know. All right. And then we're gonna do idf.py monitor and see what kind of crash or crazy error or what happens. Failed to initialize libssh. Returned from app main. And just bombed out. Okay. Well, that sucks. And I got a return code of -1. All right. Failed to initialize libssh right here. And it returned -1. And so it's doing SSH init 0. Oh, oh, oh. We are missing a very, very important piece before I even debug this at all. Remember, we added a bunch of new things to SDK config defaults. These things. And so we need those to. I don't want to delete SDK config because it's got a bunch of other things in it. Okay, we're gonna save. We're gonna save that, and we're gonna delete our SDK config, and we're going to try that. We actually just wanted to build. Yeah, great. I'm glad it gave me an error because we only want it to build. Config secure flash encryption mode development to enable. Yeah, because we did a whole bunch of flash encryption stuff. Yeah. This is going to be a pain. Okay, so no. Let's get rid of this new one. Let's make this back to SDK big. And then we need to set open to the side. We need to set these config example connect IPv6 no. That's actually not going to be a problem. Okay, so let's just go through our SDK config. and say config ESP system panic print halt equals yes is not set. So we're gonna say print halt equals yes, because that's what it is. And we're just gonna go through these one at a time. This is the slow, but I don't want to mess with all the other stuff that we have here from Flash encryption. Main task. Oof. Task stack size. Yeah, okay, so we got to make that way bigger. So we're going to make this 8192. Great. And then embed DLS threading C is not set, but we want it to be. Sometimes this is not going to work, and it may not for us, because if you're hand editing like this, you could be menu config. Make sure that you don't set certain settings that depend on other settings and all this other stuff. So we could get in trouble hand editing this, but you know, YOLO, we're doing it anyway. Embed TLS threading alt equals no. Okay, so we're just going to add that. Threading p thread. Well, it didn't find thread at all. Config embed TLS threading C. I think that was the only, yeah. So we're going to take all of these others. We're just going to add them underneath. And then NetIF API, I think is probably already yes, but let's just check. Big LWIP NetIF API. Not in there. To support build on IDF 5.3. We're on 5.5, so let's just see if we can get away with not doing that. And what I like to do here is an IDF.py full clean. Make sure everything's gone, and then let's do an IDF.py build. Now you're going to send me on a bug hunt for things that do not halt print on panic. Hey, we're not pros around here. We're just messing around. Okay, let's see if it inits this time, because we were missing some of that stuff. I don't know. If that doesn't work, we could be in real trouble, because I don't know anything about libSSH or running this. I saw this guy that said he ported it and it worked, and so I hope it does. That would be super cool. Okay, successfully loaded hard-coded private key at simple SSH server listening. Sweet. Default credentials, user, password. Super secure. That's why we call this the production ESP32 stream, because we use things like user for the username and password for the password. Okay. And just, you know, because I joke, let's go ahead and look at in our main. You would obviously, none of this is ready for production, but you can change this. I believe it was somewhere at the top here. Yes. Anyway, default username, password. Now, from our flash encryption, this, if you were to read out the flash of ours, you would not be able to see that we set the username to user and password. So you wouldn't be able to see it. You'd be able to guess it really easy. But okay, so now, like, shoot, I don't know. I feel like terminal. Yeah, I don't know. I was looking up, and this is where my SSH, how to SSH to remote. I think to an existing private key file. So I think we want to do something like this: SSH I username at server. Well, and actually, sorry, homeboy here did in the libSSH and then example server. He's saying you can generate your own keys. We're not going to do that. And then he's saying SSH user, because if you generate the key, your machine will use it. But in this case, I think we need to specify it. And so let's run alpha and prod. DPaw, I'm picking up what you're laying down. I like it. Okay, so let's come in here and grab these. Yep. So, oh, sorry, you can't see this. I'm in the repo right now, downloading the keys from the example. I'm going to create a new folder to SSH, and I'm going to save the key there. And then I'm going to come over here and I'm going to save this because I don't know what I'm doing. Save. Okay, so what I just did, now you can see here, I just downloaded those two keys, the public and the private key. And now it looks like I've got all of this right below my window here. You can see my IP address is 192.168.3.94. So I think I can do SSH-I. I think it's the key I want, SSH host key. And then I'm going to do user at 192.168.3.94. No route to host. Port 22. Now, it's port 2222. Is that, did he include that in the instructions? He did. He did. -P 2222. No route to host. I mean, ping's not going to work, I don't think. Oh. I know what's happening. I know what's happening. Daggone it. Okay. This is going to be dicey. The stream is likely going to go down because I am on my IoT. Yeah, see, this is what I was worried about. Okay. Man, I hope this, if we drop and we don't ever see each other again, I apologize. But the problem we're having is, again, my home network is a thing of beauty, at least by my own estimation. And my IoT network is separate from everything else. So all of every IoT device I have in the house is on its own virtual network on my network hardware. And one of the settings I have for that is that those things cannot talk to each other. And I can't even get to, because I'm connected to that, I can't change that setting because I can't connect to that without switching to another network. You know what? We're just doing it. I apologize, everybody. If this, the stream is 100% going to drop because I have to switch Wi-Fi networks to fix my Wi-Fi to say, hey, all of the IoT devices can talk to each other, because that's the setting. The setting is don't allow any of the IoT devices to talk to each other. They can all get out to the internet. They may not intercommunicate. And so because I'm connected to that same Wi-Fi, I can't talk to my ESP32. And so I need to flip that setting off temporarily. We're doing it. If this is the end of the stream, I apologize. We'll see how this goes.